simultaneous equation of nonlinear functions. And the first part is the 2.1, which is the maximum and minimum point. Now, let's quickly take a look at, first of all, we know that before we solve the simultaneous equation, we want to look at the brief aspect of quadratic equation. And when do we have a maximum point, when do we have a minimum point? First of all, you know quadratic equation are of the form ax squared plus bx plus c. So quadratic equation are of the form ax squared plus bx plus c. Okay, and which can be put in a completed form a into x minus h squared plus k. We can put in a completed square form of this nature. We can put in a completed square form of this nature. Okay, so when we put in a completed square form, h and k, this h, the value of h, and the value of this k become the coordinates of the maximum point or the coordinates of the minimum point. So the value of your k, the value of your h is like your the value corresponding to the x, and the value of your k is like the value corresponding to your y. So the value of h and k becomes the coordinates of the maximum point or the coordinates of the minimum point. Now, when do we have a maximum point and when do we have a minimum point? You have a minimum point when the value of a is greater than 0. When we say a is greater than 0, it could be 0.5. The a is, remember, a is the coordinate of s squared. Sorry, I say coordinate, coefficient of s squared. A is the coefficient of x squared. So when you're given a quadratic function, once you look at the coefficient of s squared, if it's 1 or 2, or in fact, if it's 0.1, 0.5, half, 1, 2, 3, 4. If once it's a positive number, we say that number is greater than 0. Once the coefficient of s squared, which is greater than 0, once is a positive number, then we're going to have a minimum point. Your quadratic graph will be like this. The solution of your graph, when your graph is plotted, you have a minimum point. The meaning of minimum point is a graph that is looking like U, that has a valley. It's as if it has a valley, has a minimum part of the slope of the graph, of the curve. So when your graph is looking like letter U, then you have a minimum point. You have a minimum point. Okay, and that happens when the value of the coefficient of s squared is greater than 0. Now, when such as this, for example, if you have 2s squared plus 8x plus 15, if you are given this kind of quadratic expression or quadratic equation, then you can see that this value here, the coefficient of x is 2. The coefficient of x squared is 2. And this coefficient of s squared is greater than 0. And it's called a. Once it's greater than 0, then you're going to have what? A graph like this. You're going to have a minimum point. You're going to have a minimum point. Now, once you have, and on another hand, if you have a is less than 0, you know what that means? It means negative numbers. So b here will be equivalent to minus 3 here. Therefore, b equal to 3. Therefore, b equal to 3. Minus will divide minus. Divide both sides by minus 1. You get b equal to 3. Now, we've found b. Now, we take the next one where we have a coefficient of x. Coefficient of x is 6, right? You come this way. Which one is the coefficient of x here? We have minus 2bcx, right? Minus 2bc. So you compare minus 2bc with what? With 6. With 6. You compare minus 2bc with 6. Because this whole thing is a coefficient of x. 2bc. Because these numbers are constant. B and c, they are constant. So minus 2bc equal to 6. You come here, you write minus 2bc is equal to 6. So you remember we already found b times c equal to 6. So you get minus 6c equal to 6. Divide both sides by minus 6. You get c to be equal to minus 1. You get c to be negative 1. Now you come to the last one, the constant. A is a constant. You come here, a is a constant. Let's take a look at this. A is a constant because it's on its own. It's not attached to x. It's not a coefficient of x or s squared. And bc squared is a constant minus bc squared. So you put this and this together. You put this and this together. And you equivalent it to 5. You equivalent it to 5. So that's what we did here. We say a minus bc squared is equal to 5. a minus bc squared. This a minus bc squared is equal to 5. Is equal to 5. Okay, when you do that, a minus bc squared equal to 5. Remember, you already found b to be 3. So you say a minus 3 times, you also found c to be negative 1 times negative 1 squared. If you square negative 1, it will become positive 1. So positive 1 times negative 3, it will be negative 3. So I have a minus 3 equal to 5, 8. Now, since a is 8, it's a positive number, then we're going to have a maximum point. We're going to have a maximum point. So we solve the first one. The first one says we should solve A, B, C. We solve A and B and C. So we have arrived at A, B, C. So that's that. The B say we will now write that put it in our completed square form. We put it in our completed square form. How? Remember you found A. The function is A. Okay, A. The function is A minus B into x plus c, right? Into x plus c. This was the function that was given to us. Into x plus c. The square. So you're going to write, put in the parameter you just solved. A was what? A is 8. So I write 8 here. Minus B was what? B was 3. You write 3 here. Then you open a bracket. X, you write your x. C was what? Minus 1. So you write minus 1 here, not plus 1, minus 1. We got C to be negative 1. And then you square it. Remember, this is our K. This is the value of A, and this is value of H. This is the value of H. So our H is 1. So you go to write 1,8 for the HK. And the maximum point, this will be a maximum point. This one will be on 8. And 1 on x-axis, 8 on y-axis. Okay, we can raise it further up. We raise the graph like this to reach 8. They pass through 1 on x-axis, the 8 on y-axis. 8 on y-axis, okay? This is the value of k, which represents 8. Is that okay? So we have done that. The second one, we solved the second one. The third one says we should write the equation of the line axis of symmetry. This is how you get your axis of symmetry. You bring this one. You say x. You say x minus 1. X minus 1 equal to 0. So you bring symmetry, this value of h. So s equal to 1 is the equation for the axis of symmetry. Then the last one is the range. Say find the range of the function f of s. The range, remember the range is the value of k. The range is determined by k. The value of k, and the value of k is 8. So you just say f of s is lesser than or equal to 8. F of s is lesser than, you can see it. You can see 8 is the value here. 8 is the value here. So you say f of s is lesser or equal to 8. So that's that for that expression. Okay. Now let's move on to 2.2, section 2.2. Let's move on to section 2.2. Here we're going to learn how to put functions or how to solve quadratic equation and put them in the completed square form. So we just finished 2.1. Let's take a look at 2.2. How to put them in the completed square form. Although we have technically taken a look at how to do it. Imagine you're given a function. You say you're be told to solve this one. Put it in the completed square form. Put it in the form. So 2 boxes. You should learn to split this one into 2 boxes. This one on its own box, this constant on its own box. So when we do that, when we learn to split, then we say half the coefficient of x. Coefficient of x is 6, right? We have it, square it. If you square 3, you get 3 squared. Add and subtract to each box. The first box, add it. Second box, subtract 3 squared. So that's what we did here. We added it here, and we subtracted it from here. We say x squared plus 6x plus 3 squared. This 3 squared is what we added to this box. Remember, the box is only x squared plus 6x. So we add 3 squared. And then we subtract 3 squared from the second box. So here we will factorize this one. Here we will factorize this one. Here we factorize this one. Is that okay? We're going to factorize. Now, like I said, we use the short form of factorization. What I say we do when we want to factorize, you just of this function, you factorized it already. Then you simplify this one arithmetically. Minus 1, 3 squared is 9. So minus 1 minus 9, you get minus 10 here. So eventually you've solved it. You put it in this form. It has also put this format. So m is 3 minus m is 3. So m will be negative 3. M will be negative 3. And n is negative 10. N is negative 10. Okay, once they ask you to put in this format, you just stop there. You don't need to be telling m, and except they ask you for this value of m and n, which is like h and k, which is h and k. So h here, if h is used, h here is negative 3, and k here is negative 10. Okay, so that's for that. Now let's take a look at another example of putting in the completed square form. You say x squared minus 2x minus 1. This is the question. You know, like I said we should break it to 2 boxes. We should break it to 2 boxes. The ones with x in 1 box, whether x squared or x, put them together in 1 box. The constant number that doesn't have x, a variable, that doesn't have a variable, put it separate in its own box. Now, this coefficient of x, you take it and you half it. You follow the three rules we've created. You half it. If you have the coefficient of x here is 2. I'm not talking about this sign, only 2. Half 2, you get 1. Square it, you get 1 square. Add and subtract. Add it to this first box, subtract it from the second box. So you simplify, you factorize this one by writing x minus, you take, remember I always say take this sign. X minus, you take this one, you put it together, you square both. Then minus 1 square is still 1. So minus 1, you get negative 2. So you put in the completed square form. This is already in the completed square form. And the value of your h is 1, and the value of your k is negative 2. Okay, so we go to the next one. Similarly, we do the same thing. Half the coefficient of x. If you have 3, you get 1.5. So you add 1.5 squared to this place, to this first one. You add 1.5 to this first box, and you subtract 1.5 from this one. Okay, you subtract 1.5. So you now factorize. In fact, after you do that, you factorize. You take this x, you take this minus sign, you put it here. Take this 1.5, put it here, you square both together. And then this becomes 1 minus 1.5 squared. 1.5 squared is 2.25. So 1 minus 2.25, you get minus 1.25. Okay, so that's that function. Now we have another one quickly before we call it a day. There are 2 ways to do this one. There are 2 ways to do. One way is to divide through by 2, the coefficient of x squared. Divide everything by 2 to make it easy for you. Or another way is to factorize 2 out between these two entities. To factorize 2 out between these 2 entities. Okay, that's another function, which is x squared plus 3x. X squared plus 3x plus 1 from here. So you say x squared plus 3x plus 1 squared, and then 1 minus 1.5 squared. So you factorize this one by saying x plus, use the sign here, plus 1.5 completed square form. If it's an equation, we say equal to 0, we continue. Since it's an expression, we stop here. If it's an equation, we continue, but this is an expression, we stop here, okay, for this one. So here's another one. Okay, but the question is, what if we don't divide by 2? We want to solve it straight away. If you want to solve it straight away, first, you have to factorize you first of all divide it to 2 boxes, right? And then you factorize these 2 out. So if I factorize that 2 out, I will now have a equals bracket. I have x squared. plus 3x plus 3x, 1.5. But you have to multiply by these 2. You have to multiply by 2. You have it to get 1.5. 1.5 plus 2, it becomes 3. So you go to add 3 square here, subtract 3 square here. So this one will become x square plus 3x plus 3 square. Don't forget this 2 outside. You keep it. Plus 3 square. Okay? And then here you say plus 2 minus 3 square. Minus 3 square. So if you don't divide this, what you do? You do your normal factorization. You get x plus 3 in one bracket. Write these 2 out. You open your bracket. You say x plus 3. X plus 3 in one bracket. X plus 3 in one bracket. And then you say plus this 2 plus 2. This one square, you get 9 minus 9. So 2 minus 9, you get negative 7. So here you get 2, this one is square, remember that. You have 2x plus 3 squared, negative 7. So that would be your function. 2 into x plus 3 square, x plus 3 square, okay, negative 7. Is it negative 7? 3 square. This one was 2, right? No, remember we factorized. It's not 1, right? 1 square 3 1. Yeah, it's not 1. Here is 1. We factorize these 2 out. If you factorize 2 out, here is now 1. Okay? Okay, the factorization also touch here. So here is 1 and 9. Okay? 1 and 9. So that's how to do that if you do. Now let's have this. You either divide through by 2 or you factorize 2 out. Okay, if you divide through by 2, you get x squared plus 4x plus 2.5. 2.5. You go. Divide 5 by 2, you get 2.5, not 1.5. Okay? So then you have the coefficient of x, which is 4. And then you simplify this one. 2 minus 4, you get negative 1.5. Yes. So this becomes your solution. Okay, so with this, this one is similar to the one we've done before. Okay, let's take a look at this. This one you can divide through by 3. Okay, so with this we come to the end of the show. Divide this one by 3. You have x squared minus 2x plus 1 over 3. Have the coefficient of x is 1. 1 square. You add 1 square to this place. You subtract 1 square here. You now have x minus. Yes, minus, not plus. Because of the sign that is here. X minus 1 square. Then you simplify this one, 1 square. 1 over 3 minus 1, you get minus 2 over 3. Yes. So this is it for this one. Okay, so with this, we've come to the end of our show. Thank you for joining us.